We've now spent quite a bit of time talking about streams, so we're now going to go back to our login screen application and apply this new knowledge to building our application again from scratch, but this time we're going to build this login screen application using the block pattern instead. We're going to use this block pattern at the expense of using stateful widgets. Let's first have a quick discussion about exactly why we might not want to use stateful widgets and why stateful widgets don't scale to larger applications. We'll then talk about how the block pattern solves some of these issues that are introduced with stateful widgets and get a better idea of what the block pattern is anyways. Now, one quick aside here, just in case you're familiar with React, as a kind of shortcut to help you understand what's going on here, just if you're familiar with React, if you're not, totally fine, don't sweat it. You can kind of imagine stateful widgets as being very much like component level state. And you can imagine this block pattern thing as being very much like using Redux. So again, just if you're familiar with that, you can kind of use that as a shortcut. Okay, so let's get to it. Let's talk about why stateful widgets sometimes come up short for larger applications. So I'm going to pull up a quick diagram here. Okay, so here's the login screen application that we put together a little bit ago and the entire component hierarchy around it. So I want you to imagine that maybe we make a little change to this application. Maybe we introduce a new control or feature on the screen, like right here or so, where we add on a little checkbox that says something like, keep me logged in. So a user can check that checkbox, and then if they enter in the email and password successfully and click submit, we'll then toggle some little option to keep them logged into the application. Now, as a quick reminder, we haven't really touched anything around authentication yet. I just mean to say, let's imagine that we have an extra little checkbox on this form for some reason. So underneath our login screen, we still got the container, still got the form, still got the column, but now I've added in this little checkbox widget right here, which is supposed to represent this checkbox. You'll notice that I've also made one other change to the hierarchy. Let's imagine that our application also has multiple screens assigned to it. So besides just the login screen, maybe our user can also navigate to some other screen inside of our application called like the user preferences screen. And maybe this other mystery user preferences screen also has this little checkbox on it that tells the user whether or not we are trying to keep them logged in. So the entire idea here is that we want to show this keep logged in button on both this login screen and also on this other user preferences screen. So if this was the feature that if we wanted to add in, this would be rather challenging to do by using stateful widgets. Here's why. The checkbox state, or kind of the fact of whether or not the user has checked the checkbox, would be recorded on the stateful widget of the login screen widget. Communicating information from one screen over to kind of a sibling screen over here tends to be a little bit challenging, or at least we have to write a lot of code to shepherd information from one screen to another. Now, it's certainly not impossible to do with stateful widgets. Definitely not impossible. We can totally do it. But transferring information from one screen to another just tends to be a little bit of a pain in the rear. So this is what that block pattern is meant to solve. Block pattern is trying to make it a lot easier for us to have one source of information inside of our application and make it as easy as possible to share that information throughout multiple different widgets inside of our app. So let's take a look at a diagram that's going to add on a block representation to this application to kind of represent this checkbox over here. Okay, so here we go. So the only change I've made is up here at the very top, I added in this green box labeled as block. So first, the term block is an acronym of sorts that stands for business logic component. And so the B comes from business, the LO in lock is from logic, and C is from component. Kind of an acronym of sorts. The idea behind a business logic component is that it's going to house all of the data or all of the state inside of our application inside of this one entity. The block component is not necessarily tied to any one widget inside of our application, and so it kind of sits outside or separate from our overall widget hierarchy. Because it is separate or outside, it's a lot easier to get access to this block from any arbitrary widget within our application. So for example, If we wanted to have our user check this checkbox right here, this one on the screen, and we wanted to make sure that updated some data inside of our application, we could form a tie of sorts between this checkbox widget and our block. So we kind of form up a little tie like that. Then, if we went over to some other screen inside of our application that needed to figure out whether or not that checkbox needed to be checked, like let's say a similar checkbox inside of user preferences that's also telling the user whether or not we are trying to keep them logged in, then our other checkbox widget over here would try to get access to our block and pull some information down into that checkbox widget. So this is in stark difference, I guess. I can't think of the word here, but it's very different from the stateful widget. With a stateful widget, we pick one widget or multiple widgets inside of our application to house all the state localized to that one widget, or all the data that kind of belongs to the login screen. So now with a block, we're saying that all of our data is going to instead live with this one object or this one class outside of our entire widget hierarchy. And then anytime that we need to change data or access data from it, we're going to form a connection from some given widget, like say the checkbox or checkbox down here, with that block. So that's the idea. We're kind of centralizing all the state into some outside object. Now, we've still not spoken why we spoke about streams for so long, so let's take a quick pause. We're going to come back to the next section. We're going to talk about how we interact with this block and why it is so important to have a solid knowledge of streams when we start using the block pattern. So quick pause, and I'll see you in just a second. In the last section, we started talking about the block pattern inside of the world of Flutter. So we're going to be moving forward into designing more applications using the block pattern, but we still have to learn a lot more about it before we start trying to write any applications with it. So in this section, I want to talk a little bit about why we spent so much time learning about streams before we could address this block stuff at all. Why do we spend so much time talking about streams and talking about how they work before we could do anything with blocks? Let's dive into this block stuff a little bit more and figure out why streams are so important. I'm going to first pull up a diagram that we looked at a little bit ago when we were talking about streams. So we had said that there's many different types of sources of events that we can use to kind of get information into a stream. Examples would be like a user typing into a text input, or a user pressing a button, or even something like a network request. These are all sources of information, and that information can all be piped into or kind of shoved into a stream, where we could then do some amount of processing on that data. And then out the other side, we would get some usable products like, say, a validation message, or I don't know, navigation, or maybe some parsed JSON data. Now I'm going to take this diagram right here, and I want to kind of open your eyes a little bit about the possibilities of sources of events up here and the possibilities of what we can really do with the output on the other side of the stream. So one example we gave of a source of an event into a stream was something like a user typing into a text input. So quick question here. When we were talking about a user typing into a text input, it was kind of in the context of working with like an HTML input right here, right? Well, how is a text input with HTML any different than that text form field widget that we were working with before? I don't think it's different at all. So in reality, when we start using streams inside of Flutter, the sources of events that we're going to have is not going to be just like, we're not just limited to the world of HTML. We can treat widgets that you and I create as sources of events inside of our application. So one possible source of events in a Flutter widget might be a text form field. Every time a user on their mobile device focuses that text form field, let's see, do I still have mine? Yeah, I still got mine right here. Every time a user focuses this input right here and types something in, that can be a source of events into a stream. Now, hopefully that doesn't sound too crazy. I don't think it's that crazy. That text form field, very similar to the inputs that we were looking at before. So I now want to focus on the other side of this diagram. So yeah, sure, we've got this input of text form field, whatever, or any other type of widget that produces some information or a user interacts with. But what's really interesting in the world of Flutter is what we can do with the output from a stream. At this point, every time that you and I have been consuming data from a stream, it has been through that listen function, right? We've wired up that listen function several times now, like this one right here. And every time we've used listen to consume information out of the end of a stream. But in the world of Flutter, we are not limited to only using listen. In the world of Flutter, there are actually widgets that we can make use of that accept streams as sources of data. So we're going to very quickly see that there are Flutter widgets out there that can take a stream as a source of data and then use that data to build themselves and display some content on the screen to our users. So when we start talking about the real purpose of blocks and how streams fit into them, it's a little something like this. So in the center, we got the block here. On the left-hand side, we have some input stream of data from some widget inside of our application. And that might be like a raised button that a user can press. It might be a text form field. It might be any type of input a user supplies to our application. That can supply an input stream, which we're going to kind of wire up or kind of have kind of funnel over or pipe into our block. So the block here is going to serve as the central location of coordination between all the different streams we create in our application. Then on the other side, that block is going to make available some number of output data streams that can be fed into different widgets inside of our application that accept streams as a data source. So let's kind of take this back to the example we were just looking at over here. So we were saying that if we change the value of this checkbox right here, we want to make sure that the same value is reflected in this checkbox way over here on the other side of our widget hierarchy. So we're going to say that we're going to treat this checkbox right here as a sort of sink or a stream of data. Whenever a user taps on this checkbox, trying to check it, that's going to issue some data event. We're then going to wire that stream up to our block because that's kind of the central location of all the streams inside of our application. So the checkbox is going to have a stream. User taps it, and you can kind of imagine a little event moving along this little pipe right here, and it eventually goes all the way up to the block. And then the block is just going to hold on to that data event until sometime in the future. Then when the user navigates over to this user preferences window over here, we're going to take this stream and we're going to kind of redirect it, so to speak, down to this other checkbox. And we're going to take that check or the tap that the user issued over here that flowed up to our block, and it's going to take that event, pipe it through the stream down to the other checkbox. And the checkbox is going to see that the other one was pressed. And so the checkbox is going to say, oh, well, that other one was pressed. Well, I guess I should be pressed too. So another way of looking at this might be something like this. So we're going to have our app widget at the top. We might have one screen on the left, some other screen, whatever it is on the right. On the login screen, we might have some information producing widget, some widget that has a stream of information. And anytime a user does something to this widget right here, that stream is going to emit some data event or say, hey, here's some new piece of information. Inside of our block, we're going to have that central location where all of our streams kind of join up together. And inside there, we might have like a transformer, or we might have a map function. We might have that take function, something that can optionally manipulate the data that's coming from that information producing widget. And then after that information has been produced, it can then flow out to some other widget inside of our hierarchy that is meant to consume a stream or consume information that is coming in. So that's the general idea. Now at this point, maybe it makes a little sense, maybe it doesn't. Maybe it makes sense, but the actual implementation seems mysterious. I think that's probably the most likely thing. So let's take a pause here. We're going to come back to the next section and start working on building out our login screen application again, but we're going to focus on the use of streams and this block pattern. So quick break, and I'll see you in just a minute. In the last section, we had a quick discussion, or long discussion, I guess, about why we use streams with blocks. So we're now going to start working on rebuilding our login screen application. We need to first generate a new Flutter project. So at my command line, you'll notice that I closed out the Flutter run process by hitting Control-C. I'm now going to go up one directory back into my sort of workspace folder, and then I'm going to generate a new project with Flutter create. And I'm going to name this one login_block. Okay, so I'm going to let that install some dependencies. We're going to take another quick pause right here. We'll come back to the next section. Now, when we come back, I'm going to have my code editor already opened up inside this new directory, and I'm going to execute Flutter run with the new project as well. So between this video and the next one, feel free to do those two steps as well so that we're ready to go in the next section. In the last section, we generated a new project called login_block. We're going to rebuild the login screen application, but instead use the block pattern this time around. Now, I got good news and bad news. The good news is we're going to learn a lot while we build this application. The bad news is that we're going to write a lot of the same code that we did back on the login screen. However, some of the code we're going to write is going to be kind of like just enough different to warrant not doing a lot of copy paste here. So sorry that we're going to have to rewrite some stuff that we already wrote, but the plus side is that we'll get some good experience with the boilerplate stuff. So let's get to it. I've already started up my emulator, and I've got the new application running inside of here. And I've also got my code editor open as well. So here's my main.dart file. As usual, I'm going to open this thing up. I'm going to highlight everything inside of here, and I'm going to delete it. Then at the very top, we're going to import just the package Flutter material.dart file. Then we're going to define our main function. We're going to call run app, and we have not created an app widget yet, but we will in just a moment. So I'm just going to put app in there right away. I'm then going to add an import statement for a app.dart file that, again, we've not yet created, but we will very shortly. So I'll say import src app.dart. So let's now create that src directory. We'll make our app.dart file inside there and create our app widget. So in my lib folder, I'll make a new folder called src. Inside of there, I'm going to make a new file called app.dart. And then inside that new file, we'll do that typical import that we're now used to writing quite a bit. We'll say import package flutter material.dart. And then inside of here, we'll define our stateless widget of app. So I'll say class app extends stateless widget. I'll define my build method inside of here, which is going to accept context. Good news, by the way, this is going to be very soon where we start to talk about this context thing that we put off for so long. And then inside of here, we're going to return a material app. I'll give it a title of log me in. I'll give it a home of scaffold. And the scaffold is always going to show a body of login screen. Okay, so far, everything just about identical to what we had previously. And of course, login screen right here is still red because we've not created that class yet. I'm going to save this file and the main.dart file. We're going to take a pause right here. We're going to continue in the next section, and that's where we're going to probably just about start writing some new code. So quick break, and I'll see you in just a minute. In the last section, we started rebuilding our login application again. We put together our main.dart file and the app.dart file as well. We're now going to create a new directory inside the src folder called screens. And as you might guess, that folder is going to house our login screen widget. So I'll make a new folder inside of src called screens. And then inside of screens, I will make login screen.dart. Then inside of here, we'll put together some boilerplate for a stateless widget. So this is already going to be the first big change. Remember last time that we put our login screen application together, our login screen widget was a stateful widget. So this time, stateless. At the top, I'll add on import package flutter material.dart, and then I'll create class login screen, and that's going to extend stateless widget. Oops, not parentheses, curly braces. Now we are building a stateless widget, so we still have to create a build method just like we have previously. So inside of here, I'm going to say return type of widget. We're going to have build. It's going to be called with some context. And then inside of here, we're going to put together some very similar markup to what we had before. So we're still going to have a couple of widgets like our Let's get one without so many lines on it. Here we go. So we're still going to have our container. We'll still have a column. And we won't quite have text form fields, but we'll see what we're going to have in just a moment. So let's at least get our container on there and the column to start. Okay, so inside of here, I'm going to return a container. We're going to immediately give this thing some margin, just as we did previously. So I'll do edge insets.all with 20 pixels. I'll give this thing a child, and that's going to be a new column widget. Remember, columns do not have a child name property. Instead, they are meant to show many widgets inside them. So instead, this thing will have a list of widgets, which we refer to as children. And then inside of here, we will eventually add in some number of fields. Let's take a quick pause right here after testing out our application. So I'm going to save this as is. It looks like we still have an error inside the app.dart file. So I'm going to flip back there and see what's up. Okay, so login screen. We have not imported our new login screen file into the app.dart file. So inside of app.dart, I'm going to go up to the top and I will import screens, login screen.dart, like so. Okay, so that error message goes away. Let's do a quick test. So I'm going to pull open my emulator. I'll do a Shift R, and right now, just going to make sure that we don't get any errors when we do this refresh. Okay, so no content on the screen. That's totally fine because we're not actually rendering anything just yet. So let's take another quick pause right here. We'll come back to the next section and talk about how we're going to now put our form together. So quick break, and I'll see you in just a minute. In the last section, we started putting together our login screen widget. Now you'll notice that inside this widget, we have not yet created a form widget as we did previously. So before, inside of our login screen, we had the form widget, and at some point underneath that was the text form field. We were using this form widget right here because it behaved as a stateful widget. And this stateful widget maintained the values of the text form fields underneath it and also handled that validation step and the saving step as well. So with this new block version of this application that we're trying to put together, we want to avoid having any stateful widgets at all. Now, to be clear, we absolutely can use a form widget and still use a block. I don't really want to get too far in the weeds here, but I really just want to show you a version of this application that uses absolutely no stateful widgets as much as possible. So this time around, we're not going to have any convenience form widget. So we're going to just completely dump that thing. Then, rather than having text form field widgets right here, which are traditionally used inside of a form widget, we're going to instead use a slightly more primitive text input widget called a, let's flip over to the other diagram, text field instead. So a text field is kind of like a multi-purpose text input widget, not necessarily one that exists inside of a form. In general, it behaves very similarly to how a text form field widget works. It just lacks that kind of integration that works nicely with the form widget above it. So inside of our login screen column, we're going to create two text fields, which are going to represent our email input and our password input, very similar to what we had before. In practice, those two text fields are going to be put together almost identically to the text form fields that we had before. So we know that those methods or those two widgets are going to get rather large. So we're going to do the same thing we did last time, where we created some helper methods to create the email field and the password field. So inside of our children list, I'll make an email field method and password field. And we'll just start with those. We'll take care of the button in just a little bit. So then underneath there, I'm going to define the email field and password field methods. So this is going to return a widget. And inside of here, we're going to return a text field. If you want to, you can absolutely pause the video right now and go take a look at the documentation for text field over on the Flutter documentation. But if you look at all the constructor name properties, you're going to notice that it's just about identical to the text form field that we were working with previously. So we still have that decoration property. We still have the keyboard type somewhere inside of here. I'm not immediately seeing it. You probably see it. Come on, where are you? Oh, right there. Keyboard type. So a lot of the things are very similar with this. So just as we did before, we'll give this thing a keyboard type, for entering in an email easily of text input type dot email address. That's how we format the keyboard nicely. And then we'll also do a decoration. That's going to be a input decoration. That's going to get our hint text of something like you@example.com. So that's kind of the placeholder. And we'll also have the label text of email address, like so. Okay, so in general, at this point, very similar to what we had before. So let's now do the same thing for our password field method as well. So underneath that thing, I'll put down my widget password field. Little typo there. I'll return a text field. We don't need a keyboard decoration this time, because remember, we were really just using the keyboard type for the email field just to make it nice to work with the email address. So no need for that this time. All we really need here is our decoration, which will be a input decoration. We'll give this thing a hint text of password and a label text of password as well. Again, kind of hard to give a hint or a placeholder on a password, but whatever, we'll keep it in there anyways. Now, quick reminder, with our text form field that we used previously for the password, you optionally can add in that obscure text property as well to get this thing to show up with the dots for the password. Again, you can use that with the text field. That's obscure text, there we go. You can use that with the text field if you want to, but for the purposes of this course, just so you can see the code that I'm writing and what I'm doing on the screen more easily, I'm going to leave that off. So ideally, in a real application, we would want to obscure that field. Again, just so you can see my code a little bit more easily and what I'm doing, I'm going to leave it off. All right, so we did a lot of typing here. Let's do a quick refresh inside of our emulator just to make sure everything is still working. So I'll do my quick refresh, my slow refresh, I'll be honest. And then we get our email address and password. Very good. All right. You know, we're kind of good on time for this section, so I think we'll just very quickly take care of the button down at the bottom as well. We'll put on that raised button element just so we're done with it, and then we don't have to take another section just to get that on here. So I'm going to add another method to my children list right here. I'll call this thing submit button. And then down at the bottom, I'll define that helper submit button. And I will return a raised button. I'll give this thing a child with text of login. Remember, we have to set up the color so it's not that boring gray. We'll say colors.blue. And I think, oh yeah, we have to add on pressed. That's what we're missing here. That's why we've got the warning. So we'll add on pressed. And we don't have anything for this to do just yet, so we'll just put in an empty function just to make it happy. And I forgot my comma. There we go. Okay, so that's looking good. Now, if you recall, there is one other thing we had to do the last time around. We had to put a little bit of spacing between our password field and the submit button, and we took care of that by adding in an extra container element inside of our children column up here. So between the password field and the submit button, I will add in a container with some margin. That'll be an edge in sets.only, and I only want to have margin on top of something like, I don't know, 25. And we'll get the comma at the end. Okay, so there's our button. We'll do another quick test. That only took about 2 minutes to do, so definitely worth just getting done right now. Okay, and there's our button. All right, so we're good to go. We are basically at UI parity with what we had before. We've got our 2 inputs and that login button. So we'll take a quick pause right here. In the next section, we'll start talking about how we're going to build that block thing and integrate it in with our application. So quick pause, and I'll see you in just a minute. We've now got our 2 inputs visible on the screen, along with our raise button at the bottom. We've now got all this UI stuff put together, but you'll notice that if we select the email address input and enter in an invalid email, and then click the login button, of course, nothing happens. So we're now going to start to pivot our attention to figuring out how we can retrieve a input out of this thing right here, validate it, and then show an error message if appropriate. Before, all that functionality was kind of wrapped up inside of that form widget that we used and the text form fields that we had previously. This time around, we instead have these text field widgets, and that's what we have to work with. So before worrying about blocks or anything like that, I first want to do a quick review or a quick overview on these text field widgets and get a better idea of how we're going to retrieve values out of them and display error messages inside them as well. So this is not at all related to the block stuff. This is just, hey, how do we kind of work with a text field? Once we understand how to work with a text field, then we can introduce the block stuff and figure out how we can validate inputs and all that kind of good stuff. Okay, so here's what we're trying to do. We've got our text field widget right here, and anytime a user enters some text in there, we want to validate that input. That's our overall goal. So in order to get a little notification or to be told anytime a user enters some text into this widget, we can add on a named property to the constructor function of the text field called onChanged. That's going to be a function that gets called with the new value of the text input anytime a user changes it. And we'll look at the documentation for this in just a minute as well. Then, when we eventually want to show an error message to our user, we can look at that decoration property. And remember, at present we have decoration right here. So inside of this input decoration object, to show a validation message or like an error on the screen, we can add on an error text property like invalid email or whatever is appropriate inside there. So that's how we're going to retrieve values out of the text field and eventually get some validation message to show up underneath the thing as well. So just to be 100% complete, very quickly we'll look at some documentation that says that is the case. Over here on the text field class, you'll notice the documentation says the text field calls the onChanged callback whenever the user changes the text. And then if we want to, we can also scroll down to the decoration name parameter here. We can look at input decoration. And on the input decoration constructor, we'll see that there is that error text right here that we can optionally provide in. So that's how we're going to kind of interact with the text field now. Before we were using the text form fields, and that was very tightly coupled with the form widget, which we're no longer using because we are now trying to implement this block pattern. So now that we understand what we're doing with the text field, take a quick pause, come back to the next section, and talk about how we're going to kind of connect this onChanged thing right here and this error text thing over here to this block using streams. So quick break, and I'll see you in just a minute. In the last section, we had a quick overview on how we're going to use text fields. So now that we understand how these widgets behave, we're going to take a look at another diagram that's going to lay out how we're going to construct our block. All right, so kind of a complicated diagram here, I suppose, but we'll walk through it step by step. This is the entire process. This is how we're going to get this form working. Now, one thing I want to point out here is that it's only showing how the text fields are going to work. We're not going to talk about the actual submit button just yet. So this is just about, hey, how do we validate some input that a user has entered into one of those fields? So we've got our column widget inside of our input screen or the login screen widget. And underneath the column is our email text field and the password text field. And as we just discussed, they have those onChanged and error text name properties that we can add on to read data out and show a validation message. So we are going to create a separate Dart class that is going to serve as our block. This block is going to have two properties associated with it. It's going to have a stream controller to be responsible for that email field, and a stream controller responsible for the password field. Now, anytime a user changes, say, the email text field, that onChanged callback will be called. When that thing gets called, we're going to take that new value that was entered into the input and dump that into our email stream controller's sink. So remember, the sink is how we manually add new events into a stream. We just pass it into the sink by calling sink.add. So the sink is going to take that new text value and it's going to pass it off to the stream that is created when we make our stream controller. We're then going to create a validation transformer, just like the one we had before when we were working inside of Dartpad. working on that kind of form validation example just a couple of minutes ago. So we're going to take that new text that the user entered into the text field, we'll pass it into the stream. The text will then run through our validate transformer. If the text is valid, great, that's fine. But if it's invalid, then we're going to add an error. We'll then wire up that error property to that error text argument on our email text field. And then the entire process is going to be identical for the password text field as well. The only difference is that we'll have a slightly different validation transformer over there to make sure that in this case we have a validation for a password, so maybe some minimum length again. All right, so that's the idea. That's how we're going to approach this. So we're now going to change back over to our code editor, and we're going to get started working on this block. So I'm going to flip back over to my code editor. Inside of my src directory, I'm going to make a new folder that's going to house all the code related to this block system. So inside my src folder, I'll make another new directory, and I'm going to call it blocks, like so. Then inside there, I'm going to make a new file called simply block.dart. And then finally, inside of this new file that we just created, I'm going to create a new class called block. At the top, I'm going to import the Dart async module, because as we just discussed, we definitely know that we need to create these stream controllers. And those stream controllers are a part of the Dart async package. So I'll do Dart async at the top like so. Okay, so let's take a quick pause right here. When we come back to the next section, we're going to start to set up our two controllers and wire up the syncs and streams on both of them. So quick break, and I'll see you in just a minute. In the last section, we started working on this new class block. So remember, our block is going to have two stream controllers tied to it, one for the email field and one for the password field. I'm now going to flip back over to our new class, and I'm going to create two stream controllers and assign them as instance variables to this new class. So inside the class body, I'll say final email controller is stream controller, and then I'll do the same thing for the password controller as well. Oops, not password controller, stream controller. There we go, much better. Okay, now I want to have a quick side note here and discuss something that came up very briefly back when we were working over with streams on Dartpad, but we didn't really dive into too much. Okay, so here is the last example we were working on over with Dartpad. Remember, we were doing the email validation, and we had that input stream of on input. We then took that stream, we took whatever value came into it, and we pulled off just that one specific property from it, and then we allowed that one specific value property to continue on through the rest of our stream. So there's something interesting in there that I want to point out. It's a quick diagram. Okay, so we have the enter email example right here. So we started off with input.onInput. That was our stream. Then whatever came through that stream, we ran through the map function and then on to transform. So the thing I want to point out here is that the types of values that were coming from that initial stream were all of type event. And I just specifically labeled it HTML event right here, just to be really clear. It was a value of type event. And then after we ran that thing through our map function, it very clearly came out with a value on the other side of type string. That was the entire purpose of the map function. We wanted to not deal with that entire event object. We wanted to just deal with the string by itself. So in this example, we have a single stream that is handling multiple different types of data. Now, as soon as we start using streams over in the Flutter world, we generally try as much as possible to only have a single type of value flowing through our stream. If we ever need to change the type of value flowing through, there is a special function tied to streams that we can specifically use to say, hey, Dart, Flutter, just so you know, we were dealing with like a string before, but now this stream is going to be handling integers instead. So back when we were inside of Dartpad, we said, oh yeah, whatever, we can throw any value we want into these streams, specifically because we did not specify a type of value. that we were going to be dealing with inside of our streams. We left the type as dynamic. And that's kind of what we just saw a moment ago right here. That's why we put this keyword right here of dynamic, to say, yeah, don't worry about the type at all, Dart. Just let us deal with whatever type of value that comes in. So now that we're working over in the Dart and Flutter world, we're going to be a little bit more stringent, or try to be a little bit more specific in specifying what type of values we expect to be flowing through our streams. So in the case of the email controller and the password controller, we're only ever going to be working with string value types. So onChange right here produces a string value, which is going to be the text input that the user just entered. And then on the other side of that stream, when we produce an error message to show, that is also going to be a value of type string. So the email controller and the password controller always dealing with strings and nothing else. And so since we are 100% assured that that is the case, and you and I are very certain that we're only going to be working with strings here inside of those two stream controllers, I'm going to specifically mark the two controllers right here as dealing with values of type string. So to do so, after stream controller, I'm going to put in less than greater than sign, which you'll recall is how we mark generic classes or customize a generic class. And I'm going to mark it with a type of string in both cases. Okay, so that looks good. Now, like I said, if we ever have a case where we have a stream that needs to deal with multiple value types, there are functions that we can use to specifically tell Dart like, hey, before we were dealing with XYZ type, now from this point forward, we will deal with this other type instead. And so if we ever get into a situation where we're going to start off with like a string value and then later on end up with something of like type double, we can totally handle that. That's totally fine. Okay, so now that we've created our two controllers and we have annotated their types, let's take another quick break and we'll continue in the next section. In the last section, we started putting together our block class. We added two instance properties to it, the email controller and the password controller. Now in this section, we're going to stop development of the block for just a second, even though we've only written 2 lines right here. I want to point out a possible issue that we might run into at some point in the future. Okay, just some possible issue that we might run into. So in this section, I want to give you kind of a hypothetical scenario around the code that you and I just wrote. So quick diagram. So here on the left, we've got our block. We just added that email controller property to it. And then on the email controller, which is a stream controller, we know that we have the sync and we have our stream. We also know that we have our email text input. And as we discussed a couple sections ago, the email text input has a onChange property, which accepts a function that will be called with the new value that a user enters into that input. And it also has the error text property that we're going to use to show a validation message on the text input as well. So essentially, we want to make sure that this property right here, onChanged, is somehow kind of like wired up to or calling the add function on the sync. Because remember, that's how we add new values into our stream. And then on the other side, after the value comes into the sync and that new value gets communicated over to the stream, we then want to produce a possible validation message and kind of pipe that back over to the error text property. So everything I just described is reality. Like that is exactly what we want to do. No hypothetical scenario there. That is exactly what we want to do. However, I want to flip back over to my code editor, and I'm going to write out a little bit of kind of pseudocode, or just a little bit of sample code, and that's going to point out a possible issue that we're going to have when we try to implement all this stuff, okay? So I'm going to go back over to my login screen.dart file. I'm going to find my email field method right here, and here's my text field. So inside my text field, I'm going to add just a little bit of code. This is not real code. Do not write this. So I'm going to put a comment here, don't write this. This is just a quick example I want to give you of a possible issue that we're going to run into in the future, okay? So our text field is going to have the onChange property. So let's imagine that we want to add that on. That's going to accept a callback that will be called with the new value inside the text field. So then inside of here, we need to take that new value and communicate it over to the add method on the sync. So think about how we would do that inside of here. We might have to write something like my block, so find my instance of a block, which presumably we have defined somewhere inside this file. And then we're going to try to get the email controller because that's the thing that is dealing with the email field. I want to get the sync property on there, and then reference add, and I'll pass in new value like so. And then we'll kind of repeat that same process of the code we might have to write to make this stuff happen for the error text as well. So the error text goes inside of the input decoration. Again, don't write this. I'm just trying to make a quick example here. So we might have to do something like error text is block.emailcontroller.stream or something like that. I don't know, something similar to that. So what's wrong here? What is the possible issue that we're running into? Well, when you look at this code, you might very quickly notice that we have this like email controller, big piece of text right here, kind of duplicated all over the place between these two functions. And especially down here inside of onChanged, we have to reference the email controller and then .sync and .add. So the possible problem here is not really a big problem. I just want to suggest that it seems like we are making our API for working with the block, or in other words, the way in which we get new values into our block, a little bit more complicated than maybe it has to be. Because we have to reference the block, and then we have to reference the email controller, and then sync, and then .add. That's a lot of things for you and I to have to remember. Personally, I think it would be way cooler if we instead had the ability to call a function on the block of something just like change email, something like that. Wow, that actually looks a lot better. Now, rather than having to reference email controller, because I mean, I don't know what that is per se. I don't really know what a sync is. I don't know what add is. That's a lot of complicated terminology. I really feel like it would be a lot better if I could just say change email. That's a super clear function name. And any other engineer who walks onto my project is going to very quickly understand what the purpose of change email probably is. So that's the problem that I want to suggest might exist at some point in time. I think that the way that we're kind of setting ourselves up over here is going to lead to a lot of kind of complicated, hard to understand code. Because again, other engineers who are walking onto your project might not have any idea what the heck a email controller is. That's not super clear. It would be a lot better in the case of the error text right here if another engineer could just reference something like block.email or something like that. Again, really clear what this is trying to communicate, or maybe email error or something. I don't know. That's a lot more clear than saying like block.emailscontroller.stream. So again, that's the problem that I would like to address. I want to make the way in which we interact with this block a lot more clear and obvious. So of course there is a rather easy way to deal with this inside of Dart. So I'm going to delete all the code that I just added. And then we're going to take a quick break. We're going to come back to the next section and we're going to learn how we can kind of set up this class of block right here to give us a lot easier access to the functions and properties inside these two controllers that we actually care about. Because outside this class, we don't really care about the entire controller. We just care about the add function on the sync and the stream. That's it. We don't really care about anything else. So again, quick break, come back to the next section, and we'll figure out how to do that. In the last section, we spoke about how we're kind of setting ourselves up for a little bit of pain with the email controller and password controller. Again, I don't want to have to write code of something like block.emailcontroller.sync.add. This way too long, and it's not really clear what I'm trying to accomplish. Instead, I want to write out something like change email, and if I write that out, I want that to kind of magically point to the add function. So that's the idea here. Now to figure out how to do this, we're going to flip over to Dartpad very quickly and look at a quick example. So I'm at Dartpad again. Remember dartpad.dartlang.org. Over here, we're going to rebuild that same block class. We're going to build a stream controller on it, and we're going to figure out how we can kind of abbreviate access to the different properties on the stream controller. So to get started, I'm first going to import Dart async at the top, because I need that to create a stream controller. And then underneath that, I will recreate the same block class that we currently have inside of our block file. So I'm going to make class block. I'm going to declare final email controller, which is going to be a stream controller for string values. And then right above that, I'm going to put out my main function. So now inside of main, I could create an instance of the block class by writing final block is new block like so. So at present, again, just to really drive it home, I would have to write out something like block.emailcontroller.stream.listen to listen to any values coming out of that stream. And then I could, like, say, retrieve that value, and then inside there, print out the value. And then if I wanted to add a value into that stream, I would have to reference block.emailcontroller.sync.add, and I could pass in like my new email. So just to test that all this code right here works, I will run it very quickly. And then when we see the output up here on the top right, we see my new email. So how are we going to clean up this API? Well, we're going to use a feature in Dart called getters. So on classes, we can add a getter, which is spelled getter, like so. And a getter gives us kind of a shortcut or shortened access to some property within that class. So in order to kind of abbreviate the access to our add function right here, I could add a getter to my class that looks like get change email. So I'm going to define a new getter called change email. And anytime someone tries to reference that property on my class, I'm going to return the add function off the sync on my email controller. So inside of here, after that arrow, I'm going to write out email controller.sync.add, and I'll put a semicolon at the end. So now, right here, rather than referencing the email controller, I can instead write something as simple as block.change email. That is a reference to the add function. So now I can invoke this and pass in my new email, like so. And now I can run this code. And we'll see my new email print out twice up here. There we go. So that's how we're going to dramatically simplify our API for accessing our block. We'll put together a set of getters that will automatically give us access to just the add function on the sync alone, because I don't really care about the email controller anywhere else inside of my application. I don't really care about the sync. All I care about is the ability to add a change to the stream controller. That's it. I care about nothing else. So I am only exposing the add function, and I don't really want to expose anything else from my class. And so again, this is not necessarily an improvement of any type. It's only an improvement in our ability to understand the code that we are writing here. So now we can do the same process for our stream as well. So I can set up a getter that will give us access to the stream. So underneath that first getter, I will write out a second one. I'll call it get email. I'm not going to call it email stream. I'm going to call it just email, because this is kind of a stream or some data structure that's going to give us access to the email. You might think, well, I want to name this something like email stream. If you want to name it that's totally fine. I'm just going to name it simply email. And I'm just going to have the understanding that this thing right here, this getter, will give me access eventually to the email address through the stream. So then for this getter, I'll reference email controller dot stream, like so. And then rather than writing out block.emailcontroller.stream, I will write out simply block.email.listen, and then we'll pass in our function, like so. Okay, now if you try to run the code right now, this will not work properly because we are trying to listen to a stream twice. We haven't quite gone into that too much, being able to listen to a stream multiple times. For right now, all we need to know is that, okay, we can only listen to a stream one time. So to get this code to work, I'm just going to remove the previous listen call right here. And then we're left with just that, so we can run this again. And we'll again see my new email print out twice. All right, and then optionally down here, we don't really need this additional call. And so I'll simplify it to be just like so. Okay, so that's the general idea. So inside of all of our blocks, we can make our controllers to create these streams of data, but then we'll usually set up a pair of getters, one that gives us access to the stream to add data to stream, and then we'll set up another getter usually for each stream that allows us to retrieve data from stream. And so if we end up having multiple stream controllers inside of a single block, we'll usually end up with a couple of getters inside of each of these sections. So if we also have, say, our password controller, then we would do essentially the same exact thing for change password. And that would go to password controller.sync.add. And then same thing down here for the password. So get password controller.stream. Cool. So getters, very useful in that regard. Now, very last thing I want to mention here, last thing I swear, optionally, if we want to, we can annotate the return type of the getter. So if we want to, right in front of the word get, we can add on the type of data that will be returned from this getter. So say in the case of our email getter down here, I could optionally annotate this as returning a stream of type string like so. Not required, but again, it will just give Dart a little bit more ability to understand what you're trying to do with your code. So in this course, you and I are going to annotate our getters everywhere we possibly can, just so Dart has a better idea of what we're trying to do. Then in the case of our add functions right here, we would annotate this as being a function that accepts a string. So I would mark this as function, and then to say that this function accepts a string, I put down my parentheses and add in string like so. And I'm going to zoom out for just a second so you can see this whole line without it getting collapsed. There we go. One more. Okay, so it looks like a good refactor. We can definitely do this inside of our block, but there's just one other thing I want to mention here. With the code that we have right now, there's still the ability for anyone who's consuming this block or any other engineer who walks onto our project, if they ever create an instance of this block class right here, they're going to see the email controller and a function called change email and this thing called email all on our block class. So I want to talk about that, just a little quick follow-up in the next section as well. So quick break and we'll come back to this example very quickly. In the last section, we spoke about how we can kind of provide shortcuts to different properties inside of a class through the use of getters. At the last section, I then mentioned that we still have this email controller property right here kind of exposed to the outside world. So I want to expand on that just a little bit. I'm going to again propose a hypothetical scenario to you. So I'm going to very quickly, I'm going to grab this getter right here. I'm going to copy it. I'm going to pull it back over to my block file, and I'm going to put it inside of class block right here. Okay, so let's imagine that we went through this process of adding in this getter called change email. So here's the hypothetical scenario. I want you to imagine that we have this class block right here, and it has the email controller and change email properties. And then at some point in time in the future, like maybe a couple weeks, some other engineer starts working on your project. Maybe on your project, they say, oh, great, we've got this block. I need to get access to that block, and I need to try to change some email or do something with the email address inside that block. So maybe this other engineer creates a main function inside of your project, and inside there, maybe they decide to create a new instance of the block. And then they say to themselves, all right, I have to do something with the email. So let's see, I'm going to write out block dot, and they press that dot, and the instant they do, they see this autocomplete appear that lists out all the different properties that are associated with the block class. Now this new engineer, maybe they don't know a lot about your code. Maybe all they know is that they need to use the block thing right here and get access to some email thing associated with the block. So maybe this new engineer very quickly scans this list of methods, and they see right here, oh, email controller. Hey, I'm trying to do something with the email. Well, that must be what I need. So they're going to say email controller. And then they say, okay, great, I got the email controller, so now I can reference sync.add, and I can add in my new email or whatever it might be. So what just happened there with that hypothetical scenario? Well, I'm not going to argue that anything necessarily bad occurred. This other engineer, hey, they don't know how this block is set up, and the code that they write, it's going to technically work just fine. But when this other engineer decides to directly reference the email controller property, they have now skipped over this really nice shortcut that we have added in here because maybe they just didn't see it, or they were going too quickly, or they didn't understand what its purpose was. So you and I just added some functionality to class block right here, and now this other engineer is saying, oh yeah, I don't really care about that. I'm just going to get direct access to the email controller instead. So again, I can't say that this is necessarily a bad thing, but I'm going to suggest that maybe if one user, one engineer like this other engineer decides to change the email by doing this line of code right here, and later on you add in another line of code later on that says something like block.change email, like so. So let's say you wrote this line of code, and this was other. Well, now inside of like one function, we have two very different lines of code that do the exact same thing. And so all I'm going to claim here is that maybe this would lead to confusing code inside of your project. I think this would not be super ideal. I think that this would make a third engineer walking onto your project say like, wait, what is this doing? Is this doing the same thing as this? I think it's just not clear. So what I'm trying to communicate here is that by allowing other engineers to even see that this email controller exists inside of our block, I think that's not ideal. I think it would be really nice if you and I could kind of hide access to this email controller inside of our class. If we could just keep it invisible to other engineers and just not even let them know that this thing exists. I think that would be really, really nice. So let's talk about how we're going to do that. We'll take a look at a quick diagram. Okay, so to hide access to that email controller property, we're going to make use of a system inside of Dart called public and private fields. The difference between a public field and a private field on a class is whether or not we can see that property or that field in some other file. We mark a property as being private by prefixing it with an underscore. So notice how right here in front of the word email controller, I put underscore right there. By just putting on that underscore, it marks this field as private, and thus it hides it to anyone trying to access our class outside of the current file. So if we took our class block after putting on this little underscore right there, if we took this class and we now imported it over to our login screen, if we then inspected class block, it would appear that it did not have an email controller property because we have marked that field as private, and that means that we are trying to hide it from any other file inside of our project. So let's try that out really quickly, just as a very quick demo. Now, I encourage you not to write the code I'm about to write. I encourage you to just watch very quickly because I'm going to make a couple of quick changes here, and I'm going to delete them very quickly. So just watch for a second. So I could optionally mark this thing with an underscore, and I'm going to also update right here, and I'm going to remove that kind of fake main function we had below. So now I can go over to my login screen. At the top, I can import, let's see, what is it? Blocks, block.dart, and then I can create a new instance of my block. So block like so. And then I could say block dot, and when I do so, you'll notice that I no longer see email controller listed inside of here. And so now if any other engineer is trying to use my block, all they know is that this thing has the change email function, and I have now kind of forced them into using change email, and they are not going to accidentally get direct access to that email controller. So that's the entire idea here. It's not something that necessarily improves the performance of our code. It doesn't necessarily make our application run better. It's solely to make our code more clear. That's all. Okay, so I'm going to clean up those changes I just made. And then back over here, since we just had kind of two discussions in a row here about these extra side topics, I'm going to undo the changes I just made because a lot of those I just said, oh yeah, don't make this change. So in the last couple of sections, we learned about getters, and we also learned about marking fields as being private so that they cannot be seen outside of our present file. So let's take a quick pause. We're going to come back in the next section, and we're going to make two enhancements to our class block right here to set up some getters on it and also mark these controllers as private fields. So quick break, and I'll see you in just a minute. In the last two sections, we had some long discussions about getters and private fields that can be defined inside of classes. Now, these two topics are unrelated to blocks in general. those two topics are all about Dart classes, and we can use getters and we can use private fields with any Dart class. So I apologize if throwing those two extra topics in here at the same time that we are discussing blocks was confusing, but it really seemed like this was the best time in the course where I can make a case for, hey, here is why you would want to use a getter, and here is why you would want to use a private field. Quick side story that I always find interesting. When I first learned Java years and years ago, I remember being told about public and private fields, and I remember sitting there saying like, why in the heck would I ever mark anything as private? Who cares? And it was only until I kind of came across this scenario that I just described where it's kind of like, yeah, I kind of don't want anyone else to know that this thing exists. I want them to use this other thing that I specially set up for them. It's only when I got that example that I said, oh, okay, I get it. That's why I would use a private field. Anyways, enough of anecdotes. So let's do our refactor here. I'm going to first mark my email controller and password controller as private fields so that no other engineer outside of this file knows that these things exist. So to do so, I'm going to simply put an underscore in front of both. Now the other quick change I'm going to make inside of here, since we now have these two fields marked as private, you and I inside this file, we kind of know what these things are for, and so I don't think I really need to be so descriptive with the names of these variables. I think that if I just called it underscore email and underscore password, I think that's clear enough for you and I inside this file to understand what is going on. I don't think we really have to call it email controller. I think that's a little bit more verbose than we have to be. So now that we've improved that, we can now set up some getters inside of here. I'm going to first set up my getters that are going to allow, or how about, what comment do we want to put here? Let's use the same one we used over on Dartpad. What do we say over here? Okay, so we're going to set up some getters that allow us to add data to the stream. So add data to stream. So we'll first set up a getter that's going to return a stream of type string. I'll use the keyword get, which indicates we are creating a getter. We're going to call it email, and that's going to return our email stream controller, which we now reference as underscore email dot stream. That's it. And then I'll repeat the same process for the password as well. And then we'll set up our second block of getters. This one's going to allow us to change data. So over here, we're going to return the add function associated with the sync of both these controllers. So I'm going to annotate the type that we're going to return from these getters as a function that gets called with a string. Because if you want to add a piece of data to either of these controllers, you definitely have to pass in a string. That's what we're saying this has to be. So I will call this first one, I'll mark it as a getter with keyword get, and I'll call it change email. I'll put down my arrow, and we'll do email.sync.add. And I'll do the same thing for password sync add, like so. Okay, so that's looking pretty good. So what you see right here is some code that we're going to see in just about every block we put together. Very frequent, very common of us to create a block, create some number of controllers inside of it, and then set up getters that abbreviate our access to the stream, or set up getters that give us abbreviated access to our sync. So now that we've got these shortcuts in here, let's take a quick pause and we'll continue in the next section. In the last couple of sections, we added a couple of improvements to our block file. So we've now got our email getter to return a stream and the password getter to return a stream as well. There's just one last thing we have to do inside this file. We are currently returning streams right here and right here, but we are not yet doing any actual validation of the different values that are coming through that stream. So as a quick reminder of one of the Dartpad applications that we put together to validate an email input right here, remember we took the onInput stream from that input, we then did a mapping step, and then we fed it through the transformer, and it was up to that transformer to do the actual validation. So we're going to end up with nearly identical code for the validator that we have to write into our project, but we have to define this validator somewhere and then hook it up to the streams inside of our block. Now to actually define these validators or these stream transformers, we're going to take a similar approach to what we did in the previous version of our login application. If you recall, we had created a validation mixin that had two functions assigned to it, and then we mixed in those functions to our login screen state. Now, this time, we're not going to mix these functions into our login screen. We're going to mix them into our block instead. But the overall idea here is that we're going to have a mix-in that we can reuse inside of our application if we have some other type of block or some other block class. So let's create a new file where we're going to make another validation mix-in, and inside of there, we're going to define a stream transformer to validate the email and a stream transformer to validate the password. So back inside my code editor, inside my blocks directory, I'm going to make a new file called validators.dart. At the top, I'm going to import the Dart async package. Now we have to do this because we are trying to make a stream transformer, and stream transformers are a class that are a part of Dart async. Then inside of here, I'm going to define my class that I'll call validation mixin. Actually, you know what, let's stick with the name of the file. We'll just call it validators. Keep it simple. Now inside the class itself, we had previously defined functions called validate email and validate password that accepted some input and then returned the result of that validation. But this time, we want to create transformers. So we don't actually have to define these inside of functions. And in fact, we probably shouldn't define them inside of functions. Because if we define these in a function, then any time that we try to reuse this mix-in, we'll probably have to call that function again and build a brand new stream transformer. Stream transformers in reality can be reused as much as we want. So rather than defining these things into some functions in this file, I'm going to instead assign them to some instance variables. So we can just make one instance of this validators class or mix it in one time and boom, we're good to go. So inside of here, I'm going to declare a new variable called validate email. We'll make this a stream transformer dot from handlers. And then inside there, we'll define a handle data function that's going to be called with a first argument of the incoming email. So we'll call that, how about just simply email? So this is going to be a string that is provided. And then the second argument you will recall is going to be the sync. And we get that sync so we can add in new events into our stream. So then inside of here, we're going to say if email contains the character @ because remember, that's what's going to make a valid email address for us. We're just looking for that @ symbol. So if we've got that thing, then we're going to add into the sync the email that we got. We're just going to say, okay, that's great. We're just going to pass this thing through and let the email continue flowing through the stream. Otherwise, we're going to look at this sync and we're going to add an error. And we'll say enter a valid email, like so. All right, so this is very similar, if not identical, to the transformer that we put together previously. One thing I want to remind you about, a little change that we introduced into the actual Flutter version of all the stream stuff, we said that we wanted to add typing onto our stream controllers so that we always have a very fixed type of value flowing through our streams. When we make a stream transformer, we have the ability to assign types to this thing as well. So when we make our transformer right here, we can add on a less than, greater than, like so, and we can annotate the input type of data that we expect to receive into the transformer, which is going to be a string. And then we can also annotate the output type as well, which is going to also be a string. And when we do so, you'll notice that if I hover over email right here, it is now labeled as being type string because we said, yep, this is going to be a stream transformer that's going to receive a string. I can also hover over the sync, and it's now annotated as saying that the sync accepts a string as well. So both of those annotations are appearing because we annotated the stream transformer type. Okay, so we can now do the same thing underneath this for our password as well. So I will do final validate password. I'll say stream transformer. I'm going to annotate this type as well. It's going to be a string dot from handlers. And then inside there, we'll define the handle data function that's going to be called with our password and with our sync. And then we'll say that if the password is greater than 3 characters, that's good enough for us. So we'll sync.add the password. Otherwise, if it's not less than or greater than 3 characters, then we're going to add in an error to the sync, and we'll say password must be at least 4 characters. Now, little typo I made inside of here, I just thought I'm saying if password is greater than 3. That's not accurate. Password is a string, so we need to get the length of it. So it should be password.length right there. That's better. Okay, so that's it for our 2 validators. We'll take another quick break here. We'll come back to the next section, and we're going to mix this class in to our block class. So quick break, and I'll see you in just a minute. In the last section, we put together our validators mixin, and we're now ready to apply it to our block class. So I'm going to flip back over to my block.dart file. At the top, I will import the validators.dart file we just created, and then I will apply it to my class block by using the mixin syntax. Remember, we use a mixin by adding in the keyword with, and then listing out the name of the mixin, like so. Now, when we do it this time, you'll notice that the word with turns red. So it looks like something here didn't quite work as we expected. If I hover over this, it says the with clause, which is talking about this word right here, which we are using to apply a mixin, can't be used without an extends clause. Extends clause is a reference to how we extend a class in Dart. If you go back over to our login screen widget, at the top, we are creating class login screen that extends stateless widget. So this is an example of an extends clause. Okay, so this is kind of an interesting error right here, and we're going to have a very brief aside to tell you a little bit about why we are seeing this. Essentially, with Dart, we cannot apply a mixin to a class without first extending it. So let's take a look at a diagram to understand why that's the case. So first, this is the diagram we looked at previously when we were talking about the validation mixin that we used on the last application. Back over there, we had said, oh yeah, when we apply the validation mixin to the login screen state, we can imagine that we really just take these methods and we copy paste them over to the target class. So that description that I gave you was kind of correct, but it was also a little bit misleading. Well, let me tell you about what's really going on. Okay, so here is some imaginary class hierarchy. We have class car. It's going to extend vehicle with drivable and parkable. So vehicle is the base class, and we are trying to apply mixins of drivable and parkable. The reason that Dart wants us to always extend a class first before we can apply any mixins is that the with syntax right here is not really talking about adding a mixin or adding the methods inside this mixin to the car class. In actuality, the with keyword right here is talking about the base class of vehicle. So what's really going on is we have the base class of vehicle. We take all of the methods on drivable and parkable. We add them to kind of a temporary copy of vehicle, and then that entire mix of all 3 of those together is then applied to our subclass of car. So in other words, you can kind of view the statement right here as almost having parentheses around vehicle with drivable and parkable. We are applying the mixins to the base class, and then the result of all that is then applied to the subclass. So that's why the thing says, hey, you can't use with without using the extends keyword, because with does not modify the base class, or excuse me, the subclass, it modifies the base class. Now, if we still want to use this mixin with the mixin syntax, there's a very simple workaround. We can either replace with extends and just have the class block extend the validators class, which in this case would work out just fine. One other possible solution to this, if we really want to use validators as a mixin, would be to have block extend the Dart base class, the absolute root class of all classes inside of Dart, which is known as the object class. And then we can apply the mixin to that, like so. So when a class block extends object, object does not have any additional methods that block doesn't already have. So no changes are made to the class block right here, but then that then allows us to apply the mixin after all, because we now have successfully extended class block before we've tried to apply the mixin. So again, we can either say extends object with validators, or we can just allow class block to extend validators like so, one or the other. Okay, so now that we have that in there, we'll take a quick pause, we'll come back to the next section, and we're going to make sure that we apply those two transformers that we just created to the two streams that we have inside of class block. So quick pause, and I'll see you in just a minute. In the last section, we added in our validators mixin to class block. So now we can apply those transforms to the two streams that are created by stream controller number 1 and stream controller number 2. So to apply those transformers, I'm going to say that anytime someone asks for the email stream through the email getter, I will give them the email stream, but first I'm going to apply the transform. So I'm going to say email stream dot transform, and then I will apply the validate email transformer that we just created and mixed in to class block. And then I'll do the same thing for the password stream as well. Okay, so that's pretty much it. Now, anytime someone asks for email or password, we're going to give them the transformed stream. They can then listen to any events or any data that comes over the transformed stream. So they will receive either a valid email or password, or they will retrieve an error message that says, hey, sorry, this is an invalid email or an invalid password. So that's just about it for class block. There's one last thing I want to talk about inside of here. You'll notice that we have green squiggly warnings underneath our two stream controllers. If you hover over them, it'll say that we have to close instances of dart.core.sync. So essentially this warning message is saying, hey, we see that you've created a stream controller, two of them here. Anytime we create a stream controller, we get a sync along with it. And by default, that sync stays open and waits for events to be added to it forever. Now, Dart doesn't like to see syncs open forever. It wants to see you and I eventually close that sync or clean it up when we are done with it. Now, in our application, you and I are never going to be truly done with these syncs, but nonetheless, Dart wants to see us add some code that's going to attempt to close those things or clean them up after we are done with them. So just to make Dart happy, at the bottom of our class, we're going to add on a new method called dispose, like so. Now there's nothing inherently special about the dispose method or the name dispose. By convention, we will add a method called dispose to any classes that you and I create. And inside this dispose method, we will do some cleanup of different variables or objects that have been created by our class. So again, for classes you and I create, nothing special about dispose per se. It is convention to call it dispose and do some cleanup inside there. So inside of dispose, I'll call email.close like so, and password.close like so. So now if we ever decide that we are done with class block, we can call the dispose method, and that will close or kind of clean up the two stream controllers that we have created. And when we add those in, you'll notice that the two warnings go away. Okay, so that looks pretty good. I think that we're just about ready to actually make use of this block inside of our actual login screen widget. So let's take a quick pause right here. We'll come back to the next section and figure out how we're going to make use of block inside the login screen. Our block is now just about complete, and the last thing we have to do is figure out how to actually use this thing inside of our application. And there's more than one way to actually apply the block to our application, so let's take a look at a couple of diagrams. They're going to help you understand the different options here. Okay, so two ways that we're going to be talking about in this course of applying a block to our application. And the first thing I want to tell you here, and I want to make this really clear, is that the idea of state management in Flutter is an unsolved problem. So Flutter is still in active development. No one really has a great answer on the best way to handle state. So I'm just giving you a couple of different options here. I'm not saying that any given option is the best one. Nobody can say that one is the best. And it's really up to the community to figure out what the best approach is going to be, and that's going to take some amount of time. So these are two possible ways of handling this. Maybe neither one's the best, maybe one is better than the other, maybe they're equal, I don't know. I just want to tell you what is out there right now. Okay, so applying a block to our application, two approaches. We're going to try applying both of these so that you get an idea of how both of them work and the pros and cons of each one. Now, in general, for this first approach over here on the left that we're going to call a single global instance, I'm going to suggest that maybe this would be a better approach for small applications. And this other approach that's going to be a little bit more complicated, that we'll call a scoped instance, maybe that's possibly better for large applications. Again, I don't know, but I'm going to give you my best take that I can possibly provide on which way is going to be better for the app we are building right now. So let's take a look at a couple of diagrams that'll help you understand the differences between these two approaches. Okay, so in this diagram, we've got our widget hierarchy here in the middle. And on the right-hand side, I've got a diagram of our block.dart file. So if we want to use a single global instance, here's what we will do. Inside of our block.dart file, we have our class of block. That's what we just put together. Then at the bottom of the file, you and I are going to create an instance of that block. So like at the very bottom, down here is the block.dart file. At the very bottom, I'll say final block is block, like so. So we have now created an instance of block, and this instance is being exported from this file. And that's what this box right here is meant to represent. This is the instance that we just created at the bottom of the file. So now, anywhere inside of our application that we want to get access to this block to either pull some data out of it or add some data to it, we can simply import the block.dart file, and then our given widget can directly access that block instance that we just created. So the impact of this is that across our entire application, we would have exactly one instance of the block. So the entire application would share all of the same data. Every single widget, all the same source of data, all the same outputs, consistent data across the entire application. Now, maybe that's the right answer for every application out there, but my gut tells me that we might not want to use that approach if we're working on a larger application. If we're on a larger application, we might want to have different blocks of different types with different values associated with them. And we might want to make use of one type of block over here and then another type over there on some other part of our widget tree. So maybe in a larger application, we don't want to be reusing the same instance of this block over and over and over again. So in that case, we would instead take the second approach of a scoped instance. So let's look at another diagram that will kind of illustrate this example. So here's our same kind of widget tree here on the left-hand side at least. And then I've added on an additional screen over here that we'll call some other screen. So let's just assume that maybe the login screen and some other screen need to have separate sources of data. Like maybe they are just doing something different between the two, and we don't really want to reuse the same block between each of these screens. So in this approach, we would try to use this scoped instances. So rather than creating a single instance of our block inside the block.dart file and then sharing that all over the place, we would instead find some given widget where we want to have a block, and then we would create a new instance of the block inside that widget. And then through a little bit of magic that we'll look at in just a moment, this instance of the block can be shared with every single widget that is rendered underneath it. So if we have some other screen right here, and then maybe as a child, some other screen renders another other screen underneath itself, like some other screen, and that gets rendered as a child to this one, then this some other screen would also have access to that same block. So in other words, every widget in the hierarchy underneath this widget right here would have access to exactly this block. But any widget that is parent to it or any sibling would not have access to it. So you can kind of see how this block right here is scoped to just this part of the tree over here on the right-hand side. So that would allow us to isolate access to that block, and we could say, hey, only these widgets over here get access to this instance of a block. If any other part of our application wants to use a block, then it has to create its own separate instance. So like we might make a second instance and assign it over to the login screen over here. And now the login screen and some other screen both have their own instances of the block that they can work with, and thus they have their own sources of data that they're going to work with. Now, setting up this approach right here involves way more code. So without a doubt, it is more complicated. Taking this more global approach, way less code. However, we get way less control over how the data is flowing inside of our application, and we don't get the ability to kind of scope or use separate sources of data inside of our app. So with that in mind, we're going to take a quick break. We're going to come back to the next section, and we're going to start applying this single global instance approach. We'll then take a pause, and we will then try also implementing the scoped instance approach as well. So quick break, and I'll see you in just a minute.